Okay, YouTube, in this video we're going to be discussing a lot of key vocabulary and basic concepts and premises for statistics, okay? So I'm going to kind of chat through a lot of these things, but starting with this, what the heck are statistics in the first place? So when we say a statistic, let's go ahead and be clear on one thing. First of all, we can refer to statistics as stats, and that's a totally fine thing to do. But we say, what is statistics? Statistics as a branch of math in general, and maybe I could try typing this here, but what we try to do is take information, which we call data, and we conduct studies to collect. I suppose I could outline these here. To collect, organize, I know that that's one important thing we want to do, but also summarize, analyze, and draw conclusions from our data. So when we talk about data in the first place, we say, what the heck is data? Well, you might imagine that data is anything that we could collect information for, but that's the important thing right there. When we talk about data, and I think this is important, we say data. The definition of data is just simply this. It is information. Okay. So when we talk about information, I suppose we could say, for an example, e.g., information might include like my height, which would be a measurement of length, or my a temperature, like my body temperature, or I could say heart beats per minute. Okay, these are all examples of types of data that we can collect, but in a nutshell, when somebody says, what is data in the first place, we say that data is just purely information, is all it is. Okay, so when we talk about statistics, what we're trying to do is gather this information, collect it, but we also want to organize, summarize, analyze, and draw conclusions from it. And reasons why I might want to do this, be a better consumer, or maybe I work in the medical field and I want to know if a certain type of treatment or a drug can be effective or produces a difference, or maybe I just need to be able to read other people's reports and maybe not do so much on my own. Okay, but in this video we're going to talk about a few of the basic premises that go with data and statistics in the first place, starting with this. What the heck is a variable? Okay, well, a variable is exactly what it sounds like. A variable, when we talk about statistics, is I'll give you the formal definition here, a characteristic or attribute that can assume different values. Okay, so when we talk about examples of variables, these could be examples, e.g. The same things that I wrote up there, but if I said temperature, temperature could be considered a variable or a random variable because the temp on any, let's say, outside given day is something that cannot be guessed exactly. Okay, so from day to day it's going to be changing depending upon the I guess the characteristics and the situation and the different weather conditions in the first place, but we say a variable is anything that can just basically assume different values. And so the variable, we could say the variable might be height or temperature or heartbeats per minute, but those could all assume different values. Okay, when we talk about what is a random variable? A random variable is exactly kind of like temperature here, but when we talk about in statistics random variables, we usually use random variable because we're talking about situations in which we cannot make a prediction as to what, or we can make a prediction as to what's going to happen, but we're not certain as to what's going to happen. Okay, so in terms of the types of statistics that we discuss a lot of the time, we refer to one branch of math as descriptive statistics, and I'll make this really easy for everybody. Descriptive statistics, the statistician, if I can spell this here, statistician simply wants to describe the data. Okay, so my job as a descriptive statistician will be to collect, analyze, draw conclusions, summarize, organize all of my data, all that stuff. But that's basically it, and I'm going to stop at that point. So descriptive statistics kind of is just really what it sounds like. When you hear about inferential statistics, we're talking about something that is a little bit different. So inferential statistics makes guesses about a population based upon data collected from a sample. So I'm using a couple of key words here, but these words are population and sample. And we want to really know these. But a population is the set of all instances of something. So I suppose I would say, as an example of like the set, for example, we could say set of all students at a given high school. That would be the population of the high school. So when we talk about the population of something, we're referring to everything in that set of things. You know, if we said the population of temperatures for the month of January would consist of all of the temperatures in January, okay? Whereas when we refer to a sample, we're talking about just a subset of the population. Okay, so that's its definition, but essentially when we say a sample, it's just like what it sounds like. Given a population of, say, all, students at a high school, if we wanted just a sample of that, what we're really going to do is maybe we go through and we pick out like every third student to be a member of our sample. So when you hear me refer to inferential statistics as making guesses about a population based upon data collected from a sample, we often say that really we collect samples from a population because the population is really just too big for us to calculate any statistics for. That is, the population of a whole high school, it might be hard to come up with the average mile time because you'd have to collect everybody's mile time. So what we often do instead is we select just a group of people from the population to represent the population. We call that group of people a sample here. So there's a picture that I suppose I could draw in here, and I will do this, but we often kind of envision it this way. We would say that this would represent the population, okay, of something here, of some variable, and this represents every element, every element. And then we would say that this right here might just represent a sample. But the sample could never be bigger than the population because the sample is a subgroup of the population itself. Okay. So in the next video, we'll get more into different types of variables and different types of data.